Drops come out really fast. That's a little bit more than 10. Put it in my boiling water bath again. Actually, I don't have to worry about contaminating this anymore because I'm done with it. But don't forget, you're going to be sharing with somebody else, so you don't want to contaminate it with somebody else. And I did clean my stirring rod before. I'll put that back in and stir it. Okay, I think I have the burner far enough away that I'm not going to set my clothespin on fire. Now you look at the clothespins in your locker, and a lot of them have little stubs of handles anymore because they've been burning and all the rest of it. I always say somebody must have taken it to the beach and used it for the bonfire and brought the remnants back. Okay, that's about a minute, I guess. One more stir. I can still hold the clothespin. That's the big thing. And this is about the same size as my counterbalance, so I'm okay there. And my clothespin is still smoking. Second washing. And one of the things when you're doing your test, if you, especially on the first time you do it, if you pour it and it's all cloudy in here, put it back in, go through the heating process again. Because either it cooled off enough that your lead precipitated out, or somehow you got some of this other precipitate transferred into your test tube that you want to save. So now this is the precipitate that's been washed. What it says is save this for procedure 4. So I'm going to put it aside to save for procedure 4. Then I'm going to continue the test for procedure 3. It says procedure 2. I did the separation. I'm sorry I didn't turn the page. That's why I couldn't find the procedure. But there it is. Cool the decantate, divide into 2 parts. As I said, it's better to divide than cool, which is the way I did it. To 1 part, add 1 drop of 0.2 molar potassium chromate. So I get 1 part here. Oh, I can turn this off so I don't break my beakers and things because I'm not going to need my water anymore. So I go over to my reagent bench. Now you won't have to hunt for it because the only thing I'll put out from this bench is the potassium chromate because that's all you need from it this time around. And you read the label every time when you're getting something so you're sure you got the right thing. And lo and behold, is it clear yellow? No, it's a cloudy yellow. I got a precipitate. Now you want to centrifuge this, but I have the other half where I'm going to test with sulfuric acid, and so I'll use one test tube as the counterbalance for the other. So now it says for the next step, add 1 drop of 2 molar sulfuric acid. And I go over here. Oh, that says ammonia. That's certainly not it. That's the HCl I used before. Nitric acid, that's not it. By the way, I know it's nitric acid because I read the 16M, but after a while this label has to be replaced, possibly before class starts. Okay, the last one is sulfuric acid. Oh, it says 3 molar. What do I do now?
It's twice as much.
The difference between 2 and 3 molar is not significant. The only sulfuric acids we have out, one says 18 molar, the other says 3. 18 molar is a big difference. 3 and 2, not much of a difference at all. So you'll find that from time to time. Some of our reagents are a few tenths different from what the book says. But the reagents in this shelf, and you know, if you see the two, and one says 0.2 and the other says 0.3, and the instructions say use 0.3, then that's the one you want to use. But if you only see 0.3 and not 0.3, you see 0.3 and 18, use the 0.3. In this case, it's 3 mil. So I'm going to put in about a drop, again, make sure the top is tight. And I'm going to make sure, and this is why you wear your gloves, by the way, you don't want to drip the drops on your finger. Now notice the other one, you didn't see it because I was holding it where I was watching the reagent, but you couldn't have seen it anyhow. But the precipitate formed immediately. This one I added the 3 molar H2SO4, and nothing appears to be happening. And I mix it. There's no lead in this one. Maybe I didn't have 3 molar H2SO4. But let me add one more drop. This precipitate forms more slowly than the other one, but not that slowly. Still not forming a precipitate. That was the other test tube. I wanted to make sure I picked the right test tube. Oh, it says it forms more slowly. I'll give it a chance, but it's not that slow. I don't think I divided it evenly because I got a nice yellow precipitate here. I didn't get my, oh, by golly, I got my counterbalance. How could that have happened? Here's my other test tube with the other half. No wonder people don't get good results. How would I have avoided that? Labeling, yes. In other words, I should have said 1/2 P or 1/2 S2. Let me go back to my chart here. Hopefully it didn't go off. There it is. So basically, where'd it go? Everything went up.
Looks like it's warming up or something.
I see
Yeah,
light
you
up
can.
there.
It's coming.
There it comes. Okay, so ideally what you're doing is filling in your chart, but sometimes you get carried away and you want to get to the end. Make sure you fill it in before you forget what you saw completely. Okay, so now I did this thing. I got a white precipitate. And you don't have to write colors, you just put a dash, that's the same as the color. So if you get nothing, you put a dash. Okay? So far I know I have a white precipitate. Then I divided it in half, and that's where I would have labeled 1/2 of S2, the solution from 2, and then I would have picked up the right one. So, okay, this was 1/2 from S2, and here's the other half from S2. Okay? So I added I can see the yellow as it formed. I don't know if it's really a yellow precipitate until I centrifuge it because the solution itself, the chromate, gives the solution a yellow color also. Okay. So far I'll just say I got a yellow one. Now I'm taking 1/2 S2. And this time I'm sure I got 1/2 S2. That was pretty suspicious when, you know, it's one of the things they have you do is you're checking different things that happen, and it is a precipitate that forms slowly, but it never formed, which means I wasn't getting a precipitate. And I panicked, as students do. I said, what do I do next? I say, go back and see where you made the mistake. Hopefully you can find it, because I don't know. I don't know what you have in your test tubes. I know what I had in my test tubes, because I only had 4 test tubes here. Okay, there I added my 2 drops. Oh, the drops have to get into the solution first. Still looks pretty clear, but now it's starting to get a little cloudy. Remember the other one? Well, you didn't see the other one because I was adding it I was faced the wrong way. But now it's starting to turn white. Now I've got some white precipitate. So now I've got my yellow precipitate, I hope, and my white precipitate. You always centrifuge things so you can see what they look like. And while I'm centrifuging, notice you have to stay near your centrifuge. And I did get a white precipitate. Can't say anything about the solution yet.
When you put that dash next to the white, was that because it was colorless, or?
Yeah, I could have written the word colorless,
Okay.
but I didn't see anything, so a dash is as good as not seeing anything.
Okay.
And the Y is for yellow, right?
Yeah, you can write the whole word if you want.
So for like next to it, will you just write yellow as well? Right next to it, would you write yellow as well? Or?
Well, I'm going to see.
Okay.
That's what I have to wait for. Because remember, I said one of the things you always do is check for completeness. And so I haven't done anything like that. Now I have here a white precipitate and a colorless solution. And here I have a precipitate and a yellow solution. So the first thing I know based on that, I did have excess chromate ion, because chromate is what gives the potassium chromate its yellow color. So I don't have to check this for completeness. Now the other question you may ask, is that a white precipitate with a yellow solution, which would make it look yellow?
Right.
This book says it's supposed to be yellow. I'll take the book's word for it. But if you really want to verify it for yourself because you don't believe the book, you centrifuge, decant. Now this decantate has to go in my waste jar. Don't put it down the drain at all. EPA wouldn't like it. The fish don't like it. Nobody likes it. Okay? Remember, I told you already about Disneyland, right? Not Disneyland. Disney Production Studios. Their cooling coils were getting coated with chromate, they think, and it's contaminating the groundwater around their building.
Yeah.
Okay? So anyhow, this we don't want to dispose of except into my waste jar. We pay a lot of money for a hazardous waste disposable place to pick those things up. And I'm always worried that what they do is they take it out in the desert and dump it in the desert and charge us a lot of money. And then they pocket all the difference. In fact, one year, and by the way, if you see any of those things, don't follow them too closely. Same thing with the radiation hazard things. Because one year they picked things up and we were telling them, don't do it like that, secure it. And they drove away, the stuff was sloshing out of the top of the truck and everything. And you're following it, it gets sloshed into your windshield. So I don't think we hire that company anymore. But yeah, there is a yellow precipitate there. You can leave it like this to show me. Or if you really want to verify it, what you do is centrifuge, which we did, decant, and then store it with water. Or wash it with water to get rid of the yellow color. And you'll find out that you'll have colorless water plus a yellow precipitate. So I'm not going to bother doing that. You don't have to do that. But that's the first one I'm saving. I put it in order so that things don't go bad or evaporate till I get to show it to the instructor. I brought little quarts. Well, where did they go?